Uh, you are most welcome, Lynn, and good morning.
Good
This is the
morning.
class that we are going to be handling, and I think we are good to
Shall I start?
Lynn, we can start.
Okay, yes, okay. Hello, everyone. Good morning. My name is Leen, and I'll be guiding you through a lesson on vectors today. I'm really excited, and I hope you are too. I've prepared a presentation which I'll be sharing with you shortly. If at any point you have questions or if I'm going too fast, please let me know, either by raising your hand through Zoom or by using the chat. Let's begin. I'll share my screen. Can everybody see my presentation? If you can see the presentation, then please type a message in the chat.
Lynn, the presentation is on. The
It's on.
presentation
Okay.
is on.
Okay, thank you. So today we'll be exploring vectors with a specific focus on vector operations, starting with addition. So let's dive in. Here's what we'll cover today. We will start with the learning outcome. Then we will have an interactive introduction with 3 activities. Then we will be coming to our main topic of today. It's addition of vectors. And if time permits, we will also touch on subtraction of vectors. We will then have an assessment where you, through a quizzes test, and we will finish today's lesson with what we have learned. So by the end of this lesson, you will understand how to add vectors. We might have an impression on how to vector subtraction, and you will have completed an assessment to check your understanding. So let's go to the first activity. So what you see here is a picture, and a boat is heading north from one shore to the other at a constant speed of 4 kilometers an hour. The water current flows east at a constant speed of 3 kilometers an hour. Now, I would like you to show me the position where the boat will actually end up after 1 hour. So please choose position A, B, or C, and please type it in the chat. Thank you. So what you see is the side of one square is 1 kilometer by 1 kilometer, and the boat is heading north with 4 kilometers an hour.
They're still trying to understand the question.
Okay. So a boat is sailing north, and north is going above, and the water is flowing east at 3 kilometers an hour. So have you ever experienced if you're on a boat or a float on the water with a current, what will actually happen? So I see the first answer coming in. Okay, I see that most of you have answered C, and that's indeed the correct answer. Well done. So now I would like you to annotate on the picture what will be the actual path of the boat. So, and I have drawn a red dot in the boat. So that's actually the position of the boat you have to start from. So please, can you annotate on the presentation the actual path of the boat, how it will be getting to sea? What will be the course of the boat towards that point? I'm waiting for some more people to have a chance to draw the actual path of the boat from its original position to this position C.
Lynn, can we first erase and we have other people draw?
Yeah.
Eh,
Oh.
Is it possible, Lynn? We
Yes, you
first
can.
clean the, okay, perfect. It is now clean.
Yeah. I am only seeing one arrow on the screen, so I'll wait for others to give their go at it.
Okay, Lynn, I think we can proceed. They're trying. Okay.
Yeah.
Maybe someone can come and draw here on board, then I can show her. Who knows the path? Who is coming to draw? And someone is going to draw it here on the board.
Okay.
I don't know that you are able to see. Okay, let me turn on the camera. Is it clear?
It's clear, but the starting point, is it
Yes?
is it correct?
Hmm. Okay. Okay. Okay.
Yes.
Have you been able to see?
Yes, I can see different lines. So what I saw on the
Mm,
board, it is the boat is going directly north and then it is following the shore. Is that the path I should understand?
okay. I think we can proceed.
Okay. So what I see is that the black line from the boat, from the red dot towards sea, this is the correct path. This is the path. I'm going to remove now all the annotations. Um, so from the boat directly to sea, the shortest path is the correct answer, and I'll show you. So what we have to consider is that the heading was 4 kilometers an hour north, and that the current displacement was 3 kilometers an hour to the east. So that's how we ended up in sea. But the actual path of the boat is directly from its origin to this point of sea, because once the boat is starting, actually the water current has an influence every time. So that's why it's heading this direction directly. So the blue path is the actual path that the boat will follow. So, but what we see now here, we see a lot of arrows. So we can now make vectors out of it. So in the vector notation. So please can you write in the chat what the vector is for the boat's heading? So what I'm looking for is for this brown greenish arrow to describe it as a vector. No. You can write your answers in the chat. Yeah, I can see a lot of good answers coming in. It is 0, 0, 4. And can you now give me the vector for the current displacement? So this would be the red arrow that you can see on the board. And if we write vectors, we have in the first position always the x displacement, and we will have the y displacement as the second number. We see a lot of answers coming in. I see a lot of 0, 3, but that would mean that the 0 means that in the x direction, there is no kilometers an hour, and in the north direction, you would have 3 kilometers an hour. And we are actually looking for going east 3 kilometers. So that would be 30. And I already see people typing in the vector for the actual path of the boat, which is correct, which is 3, 4. Because basically we go 3 to the east, means in the x direction, and we are going 4 to the north in the vertical direction. So, okay, let's go to the next activity. So what you see here, we're still with the boat. And this boat is heading east at a constant speed of 3 kilometers an hour. The water current flows east at a constant speed of 2 kilometers an hour. So please draw the location where the boat will actually end up after 1 hour. So in the starting position would be, again, the red dot from the boat. So please annotate the position where the boat will be after 1 hour. So thinking about our previous exercise, we knew that the position of the boat is influenced by the speed of the boat's heading, and influenced by the water current. So where would you think the boat will be ending up in this situation? Yes, I see first answer. So I see that is correct indeed. So basically, and you've also drawn the path. So it's gone. Somebody has removed it. But indeed, the location will be 5 kilometers in front of the boat. And the reason for that is that we have 3 kilometers an hour for the heading of the boat, but there is also a constant speed of 2 kilometers an hour for the for the current displacement. So basically we can simply add both of the vectors to get to the actual path. So let's go again for the vectors. So what would be the vector for the boat's heading? Please share it in the chat. So I'm looking for the green brownish vector. So I can see a lot of people already typing in 5, but what I'm looking is the vector notation for the heading of the boat, which is the green brownish arrow. So this would be the vector representing the 3 kilometers an hour, but this in a vector notation. So this is the 2 digits between the brackets. So for the boat's heading, it's between brackets a 3 and a 0. Basically, we are going 3 kilometers to the east, which is in the x direction, and 0 in the y direction. So that's why the vector for the boat's heading is 3, 0. So can you now give me the vector notation for the current displacement? So this is actually the red arrow, which you see here in the picture. Please write it in the bracket notation as how we are writing vector notations. Yes, I see that Jaden is giving me the correct answer between brackets. So thank you for that. Okay, Shanice and Haley are also giving that. So the current displacement in a vector notation is between the brackets, the 2 and the 0. Well done. And now we are coming to the actual boat, and I already saw some answers, and also that we can see that it's the 5 and the 0 between the brackets. So, and for vector notations, the brackets are really important, not only the 2 or the 3 or the 5. So it's important that we use the correct notation. Okay, then we are going to our final activity to conclude our introduction. And here we are still with the boat. And the boat is heading 4 diagonal squares northeast per hour. And the water current flows 2 diagonal squares southeast per hour. Now, please can you annotate the location of the boat where it actually will be after 1 hour? This is a more tricky question. Maybe it's also easier to draw it on the board. Then I can also follow it from there, just like we did just. A diagonal square is going from one corner to the opposite corner of a square. That would be the diagonal. Yes, I see the first annotation on the screen, and I can confirm that that's correct. So what you've drawn is actually good, because you have drawn the heading of the boat and the water current flow direction. So that's four diagonal squares northeast what you've done, and then you've drawn two diagonal squares southeast. So well done. Can you also
Lynn,
draw
someone
the
wants to
actual...
draw here on the board.
Ah,
Someone wants to draw here on the board. I don't
okay.
know that you can to see.
Yes.
So hope. So you're going, they want to draw it here.
Yeah. Maybe. How was it? That was super. That's it. You guys four diagonal squares. Hey, you see what? Whoever's going to draw them to see that drawing. One, three, teacher, two. Are you? Yeah. Two diagonal. One. Yeah.
Let's go, boys.
Yeah.
Let's get here.
Teacher. Was it correct?
Lynn, have you been able to see it?
Yes, I see the black on the screen, which is you ended up in the correct location. So that's perfect. So basically, I will share the screen. So yeah, you cannot see my blue dot perfectly because it's drawn over, but that's correct. So that's indeed the basis. So if we look at the heading, that's what you've drawn, and the current flow, but the actual path, that will be, of course, the shortest direction, just like what we have seen in the previous activities. So, and I can already see answers for the actual path in the correct notation in the chat. So I think that's very clear for everyone what we're doing here. So well done, excellent. So the heading of the boat, because it's diagonal, was 4, 4. And the current flow is 4 minus 2. And then it means that the actual vector is the 6, 2, what I can already read from the chat. So perfect. Now I'm going to remove the annotation, the drawings. So let's go to the next slide. What you can see here is an overview of the activities that we've done. And in each case, we identified the boat's heading vector, and we identified the water current vector, and we found the actual path for the vector. But can you see a pattern here? Can you determine the actual path vector without a drawing, just by taking a look at the separate vectors for the boat's heading and the current displacement? Do you see a pattern? Would you really need the drawing to count all the squares, or can you derive it from the vectors? I would like to see your answers in the chat.
Lynn, what do
Yes.
you want them to do?
So basically, we have in front of us the table with the 3 activities. And we see the vectors for the boat's heading, the current displacement, and the actual path. And we found the actual path and the vectors through counting the squares. But my question now is, do you see a pattern here? Would you really need to have the squares to count to find the actual path vector? Or can you derive it from the vector of the boat's heading and the current displacement? Do you see a pattern in those vectors? And if so, what is that pattern? So if you look at the first vector, the vector of the actual path was 3, 4. And we had the vector for the boat's heading, which was 0, 4. And we have the vector for the current displacement, which was 3, 4, 3, 0. So do you see a pattern, for instance, in those 2 vectors to achieve the actual path vector of the boat? So what I'm looking at is whether you can actually find the blue vector if you would have been given the brown greenish vector and the red vector. Would you be able to come to the conclusion of the blue vector? And if so, what would you have done to come to that? What you see here is that the 3 I can find back here in the blue, and the greenish, brownish 4 I can also find back in the 4. Ah, I see the first correct answer. So I hope you can see it too. So it's addition. So what you see is that the actual path vector equals the sum of the x components and the y components of the 2 vectors. So in the first example, we see that 0 plus 3 is 3, and 4 plus 0 is 4. And in the second one, we see that we found for the x components, we found a 3 and a 2, and we see that resulting back in a 5. So there was a 0 in the y coordinate and in both vectors, so that sums up to 0. In the final one, we had 4 and 2, which makes 6, and 4 and minus 2, which makes 2. So indeed, what we saw is addition. And in general terms, we can say to add 2 vectors, we add the corresponding numbers. So if we have a vector A with x1, y1 coordinates, and B, vector B with x2, y2 coordinates, then if we add A plus B, then we actually can add the x1 with the x2 for the corresponding vector, and the y1 and the y2 for the corresponding y coordinate of the vector. And in the activities we have drawn also this addition. We could see that we can find it back. And what you can see here is that there are 2 methods to do so. The first one, the top one, is that's what we call the parallelogram method. And there you place both vectors from the same origin. And then you complete the drawing by making a parallelogram. So basically you take the parallel of the red arrow and you take the parallel of the blue arrow. And from the origin to that final point, you can find our vector which represents our addition, the A plus B. You can also apply the triangle method, and this is what we have done in the activities. We have placed the first vector, and then from the end point of that first, we have started the second vector to then come to the same point. And it doesn't matter, with addition, it doesn't matter in which order you place it. You can also first draw vector B and then vector A. The addition will be the same. You will end up in the same point. So let's make an exercise, an example together. So for instance, let's have vector A, which is 3, 4, and vector B, which is 4, 6. So can you give me the result for A plus B? You can write answers in this chat. Yeah, I see the first answers. Yes, excellent, smashing. Yes, I can see that we can add indeed 3 plus 4 and 4 plus 6, which makes 7, 10. Thank you for all the correct answers. Well done. So let's make some exercises together. What you see now is that we have given 4 vectors, vector A, B, C, and D. And I'm now looking for the addition of A and B. Can you please give me the answers through the chat? Yes. See the first answer coming in. Yeah. Perfect. Correct. 5, 2 is indeed the correct answer. And so let's go to the next one, which is A plus C. Yes, indeed. -1, 0 is the correct answer. So we can continue to the next one, which is B plus C. So I see, mostly the answers are correct, but please pay attention to the minus sign in front of it. So for the next one, it was 2 minus 4. So don't forget to also consider the negative values. And let's go to the next exercise, which is B plus D. Yeah, perfect. And then the final one on this page is C plus D. Yes, perfect. I see that everybody's getting the hang of it. Well done. So -7, -1, perfect. So let's go to the next exercise. What you now see is that I'm not giving you the vectors in the algebraic notation, but what you see now is that you will have the vectors in a drawing. So we're going to do the same, but the idea is now that you first give me the coordinates of the two separate vectors, followed by the result of the vector. So let's go to the first one, which is a plus b. So please write in the chat the vector notation for a, then the vector notation for b, followed by the resulting vector notation. So please take a good look that the first coordinate is a coordinate in the x direction, and the second coordinate is the one in the y direction for each vector. Let's look at vector A together. So if you see vector A, we have in the x direction so in the x direction, we have 2 squares, and we have 3 squares in the y direction. Ah, okay, I see the answer of Hillel, Timo, David, and Ghostly. That's almost correct, but please also consider negative values in there. You're almost there. But if you look at the B, it's not going in to the right direction, but it's actually going to the left and to the south. So, okay, let's take a look at the first one together. So what you see is for the A coordinate, we have vector 2, 3, because we are going 2 squares to the right, and we are 3 squares upwards. For B, we are going 3 squares to the left. So that's -3. And we are going 2 squares to the south, which means -2 on a y-axis. So if we add those two, we will get you can also see here the picture in the bottom. So basically here I've drawn the two vectors after each other. So the resulting vector would be from the original point, the origin, to the end point, which would be, I see that Isabel is giving me the correct answer, which is -1, 1. Yes, exactly. So let's do one more exercise. So we are now looking at A plus C. So I'm curious whether you can find the answers for the vectors A, C, and the result. Yes. I see the first correct answers coming in. So if we take a look, we have the vectors 2, 3 for A, and for C we have 4, 0, meaning that the sum of them is indeed 6, 3. Well done. I can see that we are shortly for your break, so I think we should stop the exercise here. There are also a few more of that. So basically, but I'm sure that Mr. Kaziba can share you the handouts so that you can try them for yourself. So. Yes, correct. Yeah. So we have the B plus D on the yes, exactly. That's going well. Well done. Then we have there the final exercise. C plus D. Exactly. That is 1, 2. I don't know, Kaziba, whether we have still time for the final exercise or whether we should stop here. Yeah. Yeah. Yes, I think it's a good suggestion from Mr. Kaziba. We can give you these exercises for you to do later. This presentation also considers subtraction of vectors, so also that is something you could go through by yourself or together with Kaziba in a following lesson. Yeah. Unfortunately, we didn't get to the assessment, the quizzes, but I will also share that one with Mr. Kaziba. So maybe this is also something you can do later.
Yeah.
Yes.
Thank you for that lesson.
Yeah, you're welcome. I really enjoyed it. I hope you did too.
Yes, just.
Okay. I don't know you, but sit then.
Yes, yes. Bye-bye. Thank you. Have a nice Easter break as well. I think you...
Have a nice.
Yeah.
Okay. So. Okay. Okay. Thank you so much, Lee, for that great session. It was so nice. Very interactive. It was just unfortunately time, but you have really done it. It was very good. Very interactive. I've enjoyed
Yes.
the interactivity that you had with the children. Okay, let me first get some good space. Keep on. Let me just get space here.
Yeah.
Eh, Okay, yeah, sorry. Sorry. Yeah. Yeah. So I was saying, yeah, the session was very good. I love the interactivity because you kept asking them, type in the chat. So I could see every group, every child, and the class. Do you know the class had because when I told them that we have a teacher from out, everyone wanted to come and join the lesson. So the class was full capacity. I will share with you some photos when they are enjoying the lesson. Though we got some internet connectivity challenges, but at least, everything was very good. I loved the exercise and the scenarios. They were on point. Yes, I can say the lesson was very, very nice. Thank you so much for the preparations and everything. I've enjoyed and I've learned a lot. Thank you.
Yeah, thank you. I think it was a really nice exercise for me. Unfortunately, we didn't
Mm.
do the test, but I saw
Oh,
that in the beginning with the activities, it was a bit hard to I think to grasp the question. But once they were in it, I think they really
mm,
understood it well. So I think they achieved the comprehension of what additional vector is. That's from my
mm,
feeling. So in the beginning, there
mm,
were a lot of wrong answers, but I saw that through the lesson, it became much better.
mm.
So it would have been nice to see how they would have done with the assessment. But
Assess. I know I can get about, can 5 people do for us? Getting 5 children to try out the test.
okay,
Can that be good?
yeah, that's
Okay.
okay.
Now what you are going to do, you can share with me the link or the code. I don't know whether you can give me about 30 minutes, maybe around 11:15. 11:15, eh?
Yeah,
Is that okay?
yeah.
11:15 my time. We get about 5 children that have been in the lesson. Then we give them that quiz and they test it out. Can that work for us?
Yes, 11:15, eh? So we have another
Hmm.
session then with those 5 children, or and then we do it live, or do you want me to share the link and by then
Hmm.
we will, or what we do?
Of
Yeah.
which one will work for us better? Which one favors you?
It doesn't matter. I can join at 11:15 your time, and we can do
Okay.
the. Is it bad?
Okay. Yeah.
Because then we can also
Okay. Now
follow on
what
the
we have?
screen the progress.
Yes. That one can be well. Okay. Let us come back again in the room at 11:15. Then we get those children join online and then they do it.
Okay, perfect. Yes.
Yeah. Okay.
Thank you.
Kari, Kari. Okay. Thank you too.